Thank you, Dania, and welcome everybody, and also welcome to our new colleagues, especially from University of Aggar, that are going to try out HPC. So my name is Sabri Razik. I work at the University of Oslo. So I've been with the training team quite a while now. My main task these days is as the manager of the Norwegian AI Cloud. But today we'll look at some basics of HPC. So this was the document that Dania was showing. Here, you should have, everybody should have this link, just in case if you want to have a closer look what you're talking about. And I will also share the screen horizontally, so you'll have more space on your display where you are watching, so you might have some space for you to keep this document as well. The first thing I'll do is go and click on this course pages and schedule. Then I will come here as the first lesson, which is the welcome to the HPC lesson. So if you ever get lost, the only link that you should have bookmarked is this collaborative document. There you will find everything else. So start the discussion. So we have to motivate ourselves a little bit about why we need HPC. So the best way for us to do that is to have some practical, realistic examples. So we use the collaborative document Dania showed. So I'm going to click the pencil icon here. Go to edit mode, and I go to this ask the icebreaker section above the ask question section, and what we should do is write down instances where you think your laptop was, or the desktop, or the servers that you have access to, or the VMs that you have access to, was inadequate to perform the analysis that you want to perform. For example, I see that the first comment is there was some performance needed, which took about 60 hours, and it was not realistic that you keep a personal computer up and running for 60 hours. So this could be HPC could come in handy in this case. One thing is those systems, they run 24/7. So as a user, you don't have to worry about keep things up. And the other thing is the 60 hours that you spend here, we might have been able to do it faster if it was HPC system, because the HPC systems supposed to do many things at the same time. And then the climate simulation need more resources than my laptop has, so more memory, more processors, more processors with more cores, processors that could do many things at once. And then numerical ocean models restricted to very small simulation on laptop. So you do some tests on your laptop, when the analysis become bigger, you have to go to a bigger system. Whole genome sequencing, very good example, especially those things of genomic analysis, they need a lot of memory. So there's limited amount of memory a laptop or a small computer could support. So if you want 2 or 3 terabytes of memory at your disposal, you have to access these systems. One thing, Dania, that we have to sort of keep in mind is that these computers that I will show you, the computer clusters or the HPC systems, they are not much faster than our laptops. So the benefit of using these HPC systems rely on that you break down your big problems into smaller chunks that you could analyze separately and get cumulative results at the end. We call it parallel processing. So the thing you do is, if you have something very big to solve, you break it down and give each piece to number of computers, because you have this this computer cluster is a collection of many computers. So each computer will perform this analysis, and if one computer take 100 days, you could do it in one day, because you can recruit 100 computers do these things at once.
Yeah. Sabri, can I ask you to put it on the view mode, this collaborative document?
Okay.
Yeah. And before we go further, may I ask you a question about a question? How do you feel about having questions? And if I ask any questions, do you feel motivated as a participant if I ask you a question? How do you feel it? On the collaborative document, do you like more questions or?
Are you asking the audience to speak up, Adania?
No, I'm asking you how, as an
Okay,
instructor, how do you
yeah.
feel to have more questions? Do you feel motivated?
Yeah. So just go on and ask questions. So that means that you are engaged and you understand certain things. You have to clarify more things. This is the chance. So it doesn't matter that the question should be directly related to what we talk. You could ask general questions as well. Our colleagues will answer. Only thing, Daniel, you have to make sure that I don't like go in a tangent, like I don't go out of the schedule too much, but we focus the answering on the document itself.
Yeah.
So we don't, mess up the timetable.
Yeah, we will
Please do ask.
not.
Yes.
We will make sure about that.
Mm.
I just want to emphasize that you get motivated when you teach to get questions, and there is no stupid question. If anyone is wondering if one have some question may be stupid, there is no stupid questions.
No, and this is pedagogically as well. This is like the collaborative learning experience. So if you see something that as participant that you could answer, please go ahead and answer as well. So this is rather than teaching, it is kind of learning together experience. Yeah, so we have the I don't want to go much into the text here because I think it's more realistic that we have some use cases that are directly related to the audience. So I think this explains why we need, and we will include them in the next lesson. So we have collected the most important things that participants said, and it will grow. So Dania, in your laptop, how do you input something? How do you, let's say if you're doing some analysis, if it needs some input, how do you do that?
I use keyboards and I have a touchpad instead of mouse. Mostly I use the touchpad to click things and the keyboard.
Yes. And then how do you see the output of a program?
Output I see on my screen.
Yeah, so you directly type in and you directly see the screen. And inside that, there's something going on. You have some processing going on, and then there's this memory, keep things, for example, the value of a variable until the analysis is performed. Then we see things like this. Usually, you could, in offices, they would have this as well. You could directly plug in a monitor, something bigger, and a keyboard. But having these things for each of us is not that beneficial. It's better that we keep all these big machines in one room and people can share it. Do you see the benefit of that, Dania?
Yes.
Yes. So,
I don't need to keep my desk filled with the CPUs and all. And maybe more than a decade ago, I had an office with a dual core machine and it was making a lot of noise. That time I didn't have any laptops for sure, and big screen and everything is filled up. That's the first thing came to my mind when I don't want to keep everything here.
Yes, yeah, sure. So you, let the sound and main noise and be somewhere else, and you can work on it. And the other thing is, if you have to use cloud VMs or Google Cloud or NREC or any other or any commercial cloud, there is a computer somewhere else. It's like a cloud. They call it somebody else's computer. Somewhere there's some machine. But the special thing about these things, when you fix away from your desktop, the place you are working is, Dania, that there's no way for you to have the cable of your keyboard. You can't extend it all the way to the server room, and you can't have like a cable running all the way from the server room to connect your monitor. So the thing you do is you use your laptop or the computer, your keyboard and your mouse, to establish a connection and send and receive signals from this. So we'll have a look at what this means. There is that. Sorry about going back and forth. Yes. So when you type things on your laptop, so it actually get executed on the server. So in the next lesson, I will elaborate this more. Before we go into that part, then at some point you will also hit the limit in these servers. So one server is not enough. You need 2 servers, maybe thousands of servers. So if you consider this, the most popular things these days, large language models, ChatGPT and BART and so on and so forth, they need a farm of computers to do the analysis. So in the beginning, if you remember that I said that the trick here is to break down your analysis into smaller pieces, so you can recruit multiple computers to perform this analysis. That comes with some challenges. We'll talk about that as we go. Let me see whether I have a small video clip of this. So this is a sort of our old cluster, that is fixed. So this looks like this. Do you hear the noise as well, Dania, or is it the noise not there?
Not there, and its
Yeah.
video is not moving, like it's paused.
Okay. Yeah, so I think the Zoom is not that friendly with playing this video. The basic thing I wanted to show was that, so these are like pizza boxes. They are stacked on one over another, and there are no keyboards or mice, or monitors. The way you connect to these things is through network. So we'll talk about that in a moment. And in order to do that, we need to learn about the terminal, because that's the best way to connect to these systems, and also the command line interface instead of the graphical user interface. And we have some details about very powerful computers, and what exactly a cluster difference between a cluster and HPC system, and so on and forth. And some difference between cloud computing and HPC systems. So that these days cloud computers also have HPC systems behind them that you could also use. So these things you can read on at your leisure and see the comparisons. Anything else do you want to mention, Dania? We move on to the next section.
Not really.
I will highlight 1 or 2 things in this. One is that one main thing about these HPC systems, they are located on the same location, and they also have a synchronized clock.
Yeah, and the software optimization that we don't need to bother a lot about the softwares that we need to compile and run.
Yes, that is a very good point. So the software optimized, and all the machines have access to the same software. So they are connected with very fast network. So on our system, we do some proprietary networking called InfiniBand. So they are very fast network. They are geographically co-located in a room, and they have synchronized clock, which means that you could summon all this. You could recruit all these computers as if it was a single unit. Your code would consider them as like a single. You can make them consider a single unit. Then I go to the next lesson, which is how we directly work on these computers. So this part of the lesson is mainly to show you, and I will also ask you to test certain things. But Dania, later on we'll get the exercise section. So that is the place where you actually go and practice. Here, follow me on screen and see what I'm doing, and I might ask you to do certain things time to time as well, but not all the time. Is that clear, Dania? Is enough?
Yes,
what you're going to do?
Clear. And probably during the exercise we will try some of the commands we learned yesterday as well.
Correct. So the first thing you need to perform an analysis or use a cluster is to get an account. I would also like to here mention a little bit about our tab system here. So in order to have seamless sort of transfer from one system to another, we try to collect in this central material all the clusters. How would you issue a certain command on a certain cluster, and then have different tabs to indicate how would you do it in a different system. So here we have the Saga, From, and Betsy, which are the Enrich Sigma 2 systems, and Fox, the University of Oslo systems, and hopefully we'll have more systems here coming up. So this is how to apply for account. If you are here, most probably 95%, more than 90%, I would say that you already applied for a project and you have the course access and everything. And if you are, yes, Dania?
I just want to mention that those who applied for a project via the training project, which is NN9970K, it will stay at least next month for you to test out things after learning this course. But if you want to continue, and it is mostly if you are a project owner of some supervisor, those who are supposed to apply, those who are applying for a project, and you will be part of that project. So project owner and the user project owner has more administrative power on this project rather than the users.
Thank you, Dania. So you could also try out the Fox cluster if you're University of Oslo or one of our collaborators. So the thing that I said in the beginning, so your cluster which lies on the other side of the network here, and you are here on your laptop. So you don't want to you want to type something on your laptop, your keyboard. You want to use the keyboard of your laptop in order to give instructions to the cluster. So that is the part that we have to be very clear about when we're using these things. So all the commands you type go through the internet or the local area network, and they are executed on other side on one computer. Like when you establish a connection in a moment, you will see that it is not that we have just executing the commands on all the computers. So you will land on one computer, which we call the login node. And then from there, you can provision your jobs to the cluster itself. So do you remember what SSH was, Daria, yesterday?
Yeah, that's the protocol we used to connect to the to Saga yesterday. I think we all did that.
You did that. So I'll just a reminder is the SSH is a protocol and also a command in Unix. A protocol is a set of standard rules that are set. So the SSH is a secure shell. So that's it. That is a way to establish a connection securely through the cluster, so you can send and receive data from it. So the cluster should have something called a SSH server to accept connection, and your laptop or your desktop or the mobile device that you're using should have a SSH client, which could establish connection. So for this, we could also use many operating systems. If you are on a Unix flavor, Ubuntu or any other Unix flavor, or Mac OS, SSH is already there. You can directly use it. Even on Windows computers, the latest versions, if it is not more than 4 or 5 years old, if it is newer than that, you can use the Windows terminal as well. So before so even if you don't have a terminal, you could install this software, but I think most of you would be okay. If you have any issues, use the HackMD to get help. So the first thing I want to ask my computer, Dania, is that whether I have SSH. The way I check that is I will ask SSH, a dash or a minus sign, and a capital V, a big V. And when I type that, I should get a version number. The version number that I get, it doesn't have to match what you get. It could be many versions. So you need to have something. So it shouldn't print there's no command found or there's an error. So please find your terminal. So now I'm asking you to do something with me. So open your terminal. So then we'll have time to fix anything if it's broken. open your terminal, find your terminal. If you don't know how to find your terminal, we have a lesson yesterday about finding the terminal, or ask the HackMD, the shared document. And once you found SSH, so one more thing is, if you use a small v, it will give an error. So it has to be a big V, right? And mention on the on the shared document that located SSH. I'll give about 1 minute for you to locate your SSH, your terminal and the SSH command.
So we don't, as of now, we don't care about the version. We just want to make sure that SSH is there, right?
Yes, a version. So it doesn't have to be because this is only to establish a connection to the cluster. So everything else we do it there. Don't try to update SSH or anything. So any version should be okay. If you try to update now, you might have issues following the rest of the lesson. It's not obvious. It comes with other libraries as well. Stay with what you have. So this one person who said no, could you mention here as under number 4 what was the exact issue, if you can, if you may?
Okay.
Yeah. Is that you couldn't find the terminal, or is that SSH was giving an error message? Okay, I will move on now because most of you have found the SSH.
Yeah.
Yes, Daniel?
Yeah, just yeah, I think it may be someone mistakenly put the O there because we didn't get any reply.
Okay.
I hope.
Yeah. So that's good. Assume the best. So then we are going to connect to the cluster itself. As you see, we have tabs. So I'm going to use the Saga tab today. From is down. You could also try Betsy or Fox, but I recommend that you follow it on Saga. So we will have the same result. So the way we establish our connection, as we saw yesterday as well, is that we would type, I'm going to use a Unix command called clear to clear this my screen, so I'll have some more space for you, is to type SSH, small letters, my username on Saga. This you should use the username you got. You shouldn't use my this capital my underscore user either. You should replace this with the username you have got from the Sigma2 Enris accounts. Then I would say sigma2.no. So this is the address of Saga. So like our houses, we have addresses. These clusters, they have a specific address on the internet, so we can find it. So there's this SSH command. We'll find the cluster using this address, and it will log in, try to log in you as this user. So when you press for the first time, if it is first time that you are logging in, you will get a warning saying, are you really want to log into this place? You have never been logged into this place before. Do you really want to continue? The reason is you might mistype this. For example, if the sigma2.com, for example, some malicious people might host similar name software. So when you try to log in, they might actually catch your password or anything, password or other sensitive information. So in the HackMD, I think yesterday we placed as well a link to verify the fingerprint of Saga. So I think we should paste that today as well. So if the fingerprint matches, you would say yes. Then it will ask for the password. The trick here is if you are logging for the first time, you will not see the password being typed, but it's typed. So if I scroll a little bit up again, I typed ssh.saga.no, and then when I asked for the password, it prompted me. But in Unix, you will feel that certain commands will not even return results. This was not obvious that for some people that I use my keyboard, but I don't see anything. So for security reasons, you will not see that. Then you get a welcome to Saga message, and then you'll be in Saga. Then when you land on Saga, I will also tell you how to get out. It is the command exit. Then you'll be back on your laptop. Then if I ask the host name, the name of my laptop. Now this is the sort of ID that I have my for the place I'm logging in. And the way I logged in was SSH, my username, Saga, and then the password. And as you see, second time it didn't ask for that key verification because I have logged in once. So the second time it will not ask for the key verification. So I would say that then also you could ask when you land on Saga, when you are logged in, you will be having your home directory. So this directory will be accessible from all places, all compute nodes and login nodes. So this is where you place your home directory files, not like big files. You have a limitation of 20 gigabytes, and within that you can place files there. And the other thing is the host name, the name of your computer. So you will be logging into login 3. I have logged into login 3. You might log into 1, 2, or 4 or 5 even. So this depends on which one has the least load. So the hostname command might print something different for you. Then the way to yes.
Just a question. I was a bit distracted. I'm not sure you mentioned it. You said about the login nodes. What is exactly that?
So more of the login nodes will come very soon. So these are the place you land on the cluster. So logging into the cluster does not mean you're logging into the entire system. You're logging into one machine. So that is the machine you start working on, and then you start working or uploading files, installing small software, for example. So these things we call the login node, where you end up when you type SSH.
Okay. So you are just saying that many will be ending up in a different number of login nodes. We have a couple of login nodes on Saga.
Correct. So you have 5, so you could be ending up on any one of those. Thanks. Yes. So then what we do is, Dania, we will try to log in. So I want everybody to use their terminal, SSH to Saga, log in, and use the 2 commands, hostname and pwd. Sorry. So when you type a command, if the command does not exist, is something that the Unix doesn't understand, it will say command not found. So pwd, print working directory. Try these 2 commands on your laptop or the computer that you are in, and also after logging in, try the pwd command. So Dania, what I want you and everybody to do is open up the terminal, use the SSH command that I used to log into Saga, and then use the commands hostname and pwd to print your home directory. So when that's done, please indicate that you managed to log into Saga. Yeah, thank you very much for already placing this poll. Yeah, please fix that. So it's very important that you inform us actively these things, so we can help you, or maybe we can slow down, or we could discuss more things. If you did not manage to log in, please ask it as a question, not under the poll, but ask it as a question here. I get this error, so then we can specifically help, or even maybe we could arrange someone to help you personally later on. So yeah, it's possible to choose login nodes as well. So that's as people try to, until they log in, I'll also show that. You could say login 2.saga.no. But if you do that, it's not guaranteed that you'll end up in the least loaded machine. So this, then you'll specifically load machines, a specific machine that you log in. One reason that you do this is in something that we'll not discuss today, but something called interactive login. You could start an interactive login on one node, and then you could have this TMOX session, something that will persist after you log out, and then you can connect to it. We're not going to talk much about it. We have some details. I'll share later. So you could actually specify the login node, but this will not guarantee that you will end up on a least loaded node. Okay, so I typed it. So it's a very good thing. Yeah, the login node is not that I modified my username instead. So it's login 2. It's like this that you log in. Yes. Then you type the password. Then you guarantee that you end up in login 2. But the good practice is not to use the name of the login node unless you are specific. There's some specific reason. So how does the poll look, Dania? So we have
the poll looks good. There is one person who needs to fix the login, and I'm helping the person here. It will take 5-10 minutes to reset the password and things, but we will come back to that. Means directly I'm in contact with that participant. Yeah,
so we will not wait for that. We'll move on then in that case.
Yeah, that's okay. They can follow this until it will take 15 minutes after resetting the password to login, but we are not going to do the exercise before that. So that's fine, I guess. Thank you, Sabri. You can continue.
Yes. So then after you log into your home directory, so yesterday we used a command to come back to your home directory. So it's to make sure that some people might have tried certain things. I'll type the command cd and clear in order to sort of come back to that my home directory. If I have been moving around. So I typed 2 commands very fast on purpose. The reason is to show you that I record my history here as well. So the last 3 commands I type will also appear here, just in case if I accidentally type something fast and it just disappears on my screen. You could follow that on the bottom of the screen. So these were the 2 commands I typed. Then here it's asking me ls, because I have been using this cluster for now quite a while. This home directory, I think about, I don't know, 7-8 years maybe. I'll have a lot of things collected here. So I'll have a lot of files which you might not have. So the ls is the command that we used yesterday. And if there are some hidden files that you might not see, then you have to ask LSA. So these things I'm typing, you are welcome to follow me as well. But it's better that you just watch what I'm doing and then you practice it during the exercise. But if you're a confident user, you could also follow what I'm doing. So if you want to see it, so can you tell me like instance that you need to see hidden files, Dania?
You mean the dot files?
Yeah, yes.
Yeah.
Okay.
When I have this conda files things.
Yeah.
That's the most things. And sometimes I use this git files at the .git where the story this stores the history of the Git repository, and the Git ignore file. When I create, I use the dot myself.
Yeah, those are very good examples of so instances that you use. And another place is the local, where the pip installs end up, or if you use easy build, that we'll talk about a little later.
Yeah. And the bash rc dot, that is already created most of the case, I guess.
Correct.
But yeah, we might not use an executive file. I mean, the files when you have a run script, and after you compile it, you will get a dot hidden file to dot a dot out most of the case, or something like that.
Yeah, are you talking about compilation now, Dania?
Yeah.
Okay. Yes, I will just say yes and move on about that. I don't want to complicate things. So you have been like a heavy user for a while now. So yes, if you compile it on your home directory itself, there might be temporary files as well. Then we talk a little bit about, so Dania, our next break is at 9:55. Is that correct? Yeah.
We have break at 10 o'clock.
Okay. Then, so as I said in the beginning, you have your laptop, you have the internet or the local network to end up in a place called login node. So that is the place you end up in the cluster, not on the entire cluster. Here you log in, you can copy files, install software. So I think later on there'll be some best practices about installing software as well. So if you do it as a job that we'll talk about later, you'll have some more documentation of what was installed. But here you could install software, pip installs, conda installs, even compilations that doesn't take days. Submit jobs and monitor jobs. Jobs we'll talk about in a moment. But the actual workforce is behind that. So that is where we perform the analysis. And today's main lesson is how to use these machines. So there is some things that you need to learn in order to understand how to use these machines. So after you logged in, you don't start running things as in your laptop. In your laptop, we start a program with a double click or open up the terminal and start running. We don't worry about much because it's our laptop and we are the only people using it. But this is a shared resource. So when you log in and if you start running jobs here, long jobs, then other people might have issues even logging in. So that will clog the system. So the big jobs on cluster, logging in on the login nodes. Then we can ask about the login node, as I may have mentioned, that it's a collection of many computers. So we can ask this sinfo command is a very useful command to use. Sinfo will print information about this cluster, the computers, the compute nodes, what's behind this login node. So if I ask before the sinfo command, if I ask this command will be there on the material as well. I'll show that later. I'm jumping maybe a little bit. I just want to show that how many processes are there on my on the Saga login node before I go into the compute nodes, and also memory. For example, sorry, and also the memory. So this has like limited amount of processors and limited amount of memory. So the reason I'm showing it is that if you start running things, you will only have this. You only have this at your disposal. You don't have the power of the cluster. So sinfo would give it will print a long list now because there are a lot of nodes. So all these are computers each. So this is the rack 2 16th computer. So this computer you can ask to run a job that lasts up to 7 days. So there are different words here that we will use, we will explain in the next lesson. In summary, everything that is available would be printed here. And even some things are not available also printed, but it will print with a specific message. So these are the compute nodes. So these compute nodes would have much more memory and much more processing power than your login node. So what we're going to learn next is to see how we can recruit these things to do our job. Anything else that I missed, Tanya?
No, Sabri. So Sinfo is giving you an overview of all the compute node status and other things. I mean,
Correct.
okay.
So these are regular nodes. If you open up them, you will have the processors, you have a hard drive to store things, and a shared storage to store things that should be accessible for all the computers, and also local storage that's only accessible for that computer. And you also have some temporary memory. So this is the command I used before coming into this place to see how many processors I have. So there are different ways to identify number of processors. The reason it is emphasized here is to show you that the login node is not the cluster. It is only one computer.
Yeah. Just a comment, Sabri, this npros all commands may not work in all the system. For example, sometimes Mac will not take these commands. That means it's not, the command is not pre-installed on Mac.
Thank you, Danya. So maybe LS, this CPU might work. I don't know. So it'll print number of CPUs. So there might be a command that is equivalent to your operating system to find out how many cores you have. So the shared file system, will emphasize a little bit on that. If you place something here, it will be accessible for all the compute nodes. But this is a parallel file system. Parallel file systems, they are very good at handling big files, but millions of billions of small files could choke the system. So if you have billions of files or even millions of files, better to keep them as archives, not as individual files, and extract them only when you analyze them. So then we have the login nodes, and then you have the compute nodes. If you place something on your home directory or your project directory, you don't have to worry about copying them back and forth to compute nodes. They all have access. Any questions about this already? Okay. All software, yes. Yeah, so these are some good questions. We'll talk about them when we come to jobs. What kind of GPUs are available? Sinfo would give you that information as well. Here, the machines that are designated as accelerated nodes, they are with GPUs. So you could also, I could maybe SSH, but you wouldn't be able to SSH unless you have a job running there. So don't try this command, it will not work. What was Optimus node? Accelerated, yes, 4. So you could log into one of those machines. Yeah, so you can't directly log in unless you submit a job. Later on, we'll check that. If you log into this one, then you would see what kind of GPUs. I think those are on Betsy. They were either V100 or A100s. So I will check that. Actually, maybe I can try local login. Yeah, so the admins might have wait login. So no. So you have to go to that machine to find out. If I have time before the end of the lessons, I will try to get that information. Yes, those are the things I wanted to mention. So SInfo, I will show you the man page for this. Maybe the command we grep yesterday. You can ask GPU. How to find GPUs.
I think you can say Excel, probably Info Excel. The GPU nodes are Excel nodes, right?
Okay, let's try that. So if our colleagues, if you find the SInfo command to find GPUs, please mention that. No. So the yeah, that's little sad that I couldn't find the command to find the GPU.
I think Sinfo. You are doing man Sinfo, Sabri. That's why you are not finding that.
Yeah, so I wanted to find out how to get the flag to get the SInfo GPUs.
Oh, yeah. If you try Sinfo with grep Excel, you will see which are the GPU nodes.
This one I did, Dania.
Not with man.
Okay, just like this.
Yeah.
Yeah. So what we want to do is to find out what kind of GPUs inside these things. Okay, actually the C4 is down. Let me try one of the other ones. Yeah, now actually I managed to log into one of those, but don't try to log in this because you will not get a job. So NVIDIA SMI, the card we have is Tesla P100s with 16 gigabytes of GPU memory. We have 1, 2, 3, 4 cards in each machine. So those are the, so I'm glad that I could answer that question. Host name. Dania, what we do is we'll take like a little early break because then we can actually transfer that time for exercises. So or answer questions. So we'll take the break now.
Yeah.
Right, and come back in 10 minutes, and we'll try
maybe
to
15 minutes. The break was like a 15 minutes long break so that people can have a bit more time for a coffee. And also, shall we come back around 10 past 10?
Yes. 5. Yeah, okay, fine.